So today we're very happy to have Professor Arani Bhattacharya visiting us today. Professor Arani Bhattacharya is an assistant professor at IIT Delhi, India. He received his PhD degree from Stony Brook in 2019. He works in the field of wireless networks and edge computing. His recent works are focusing on emerging applications over wireless networks. I believe today he's going to present to us their latest work, which is accepted for presentation at the Usenix Annual Technical Conference.
Yeah, 2 weeks. Yeah. Okay. All right. Thank you, yeah, for the introduction. So, good morning, everyone. So, I'll start with the discussion of this and of this paper. But in the middle, whenever it's required, feel free to ask questions. I'll also have some tutorial material just so that people who might be interested in getting into this topic might get a better understanding of the background. So the title of this paper is TILECLIPPER, Lightweight Selection of Regions of Interest from Videos for Traffic Surveillance. And this has been done, all these are students of IIIT Delhi. So the first author is the PhD student, the others are undergraduate students there. So first let's understand for just as a basic, at a basic level, that why we care about this problem. That overall, if we look at it, that a significant number of fatalities happen through traffic accidents, and the World Health Organization has identified this as a major problem. And because of this, there was a decade of road action for road safety that was planned. And in this decade, this enforcement of traffic rules became a high priority area for governments. So a large number of traffic cameras started being installed, and today almost all cities have at least thousands of cameras that are actually running. So that includes places in India too. So this is the data from India, where we see roughly an exponential increase in the number of traffic cameras that India has currently.
This is countrywide.
Which one?
This the plot in the
on the left.
On the other one.
This one is India's data.
All of countrywide.
Yes, countrywide. Yes, but from the National Highway Authorities of India. Yes, the left is worldwide. Okay. Now, then the question that comes up for us is that how does this traffic surveillance work, and why is it a challenging problem? So the way it works is relatively simple, that you have a camera installed, and that camera streams the videos to the cloud server, which uses some sort of deep neural networks to understand what is happening over on the roads. Okay. Now, this video needs to go over a wireless network, and the reason we need to stream these videos is that traffic cameras generally have very limited compute power, which means they, in most cases, cannot run very heavy neural networks that the cloud can. And similarly, the issue that comes up because of this is that there is a high bandwidth cost, and the amount of data sent can be relatively high. So the goal of most of the optimizations of traffic surveillance is that how can we reduce the amount of data that we are sending. Okay. Now, that actually has been looked at by quite a few prior works. We are not the first one to do this. So I'll just briefly explain the approaches that people have used so far. So the first approach is what I call as frame pruning or filtering, where you see that because videos are a sequence of frames, so you can identify that for my end application, which frames are not so useful, and you can remove those frames. So if you have something like this here, so you see that here you have a total of 4 frames. Maybe I find that only 2 frames are necessary, so I remove the rest on the camera side itself. That would reduce the bandwidth. Okay. Now, of course, that needs access to the raw frames, and that itself would be a challenge because often the cameras that are sold to us on the market, they don't actually give us access to the raw frames because they encode them in videos which are already packed as a sequence of frames. So the next strategy, which also has been proposed, so this is called quality pruning, where the idea is that instead of reducing frames and so on, why can't we just reduce the quality of the data? Because video data has a lot of redundancy, and it's possible that that much of quality is not needed. Now, one possibility that exists today is that on the server side, using some sort of neural networks, the technique is called super resolution, you can enhance the quality of the video. Okay, again, this is a possibility that multiple papers have explored. So the disadvantage of this approach is that it requires high GPU usage. Okay, and at one point of time, this was considered a minor annoyance, but today, with more awareness of the implications on energy consumption and with large number of cameras, this is actually a serious problem. And the third technique is called the spatial pruning, where the idea is that in most cases, you don't need all the video content. Instead, there are some objects of interest on which you are interested. So here you have these vehicles that are moving on the road. And because the if camera is static, so you don't care about the parts of the roads and so on. Instead, you just care about the vehicles. If you could somehow remove all these parts, the background parts, and you still have all the relevant information. Yes.
The background subtraction.
Yes, this is a type of background subtraction. So as of now, I have not talked about any. I have not done any of this. So this is what people have approached the problem.
So
Yeah.
before you go, I have a question, but maybe you said this, or maybe you what is the architecture of the real system you have in India, right? Or is there any compute at the camera itself, or is it some wired network that else they make?
The currently deployed systems?
Yeah.
Oh, it's mostly wired, and the cameras are not smart cameras. So there is virtually no compute capability at all. It's just encoding, send it over the wire to some server, where also in many cases in India, there is no compute at all today. So when there is any reason for the law enforcement agencies that something has gone wrong, then they go and open the videos. That's the infrastructure in most of the situations.
So there is nothing happening real time closed loop here.
Yes. That's the
Okay.
situation in those cameras that I talked about.
And any use of wireless at all?
Okay, some people are talking of wireless, but it's still quite rare. Currently, not much.
Okay, thank you.
But that's not the situation in other countries. So in a lot of countries, including the US, you have a lot of these deployments already. So then we come to this question that how to reduce the amount of redundant data that we are sending without any additional compute overheads. Okay, so we want to minimize the compute overheads. Okay, so I'll now explain how we approach the problem. So beginning with some other applications such as 360-degree videos, VR streaming, and so on, there was this idea that you could encode the videos in tile format. Okay, so so what are these tiles? So tiles are actually this these spatial rectangular blocks into which you could subdivide the videos while encoding. And the advantage of tiles is that you could actually use them as independent video streams. Okay, so effectively across tiles there are no dependencies. So you can decide that I will remove one tile, or you will change the quality of one tile, and you could still play the rest of the video as usual. And this has been done in the context of 360-degree videos quite often because the spatial content is too large there. So you want to bring specific portions only. You could remove it in this way and still. So this type of manipulation does not require re-encoding of the video. Okay. Now the question is that can tile removal reduce bandwidth? So this is sort of obvious to people who are in the domain of video streaming that yes, it can. If you remove the tiles, then slowly the amount of bandwidth that would be consumed would definitely reduce because you are sending less content now. Okay? But then comes the question that how would you actually filter if you have this type of traffic condition? How would you actually filter the irrelevant portion, right? So you could possibly design an architecture where you first get this, the camera observes this first image, then it basically encodes it in the form of tiles. Okay? Now, once it encodes, then you have to find some way of identifying that which tiles are relevant. Okay, so there has to be a step of selection. And then once you select, remove the tiles that you did not select, and then you can stream the entire video. Okay, theoretically, this is the architecture that we are trying to actually get. Now, there are a significant number of hurdles in achieving this, which is that how do we achieve this type selection? Okay, because I said that we don't want to run a neural network on the camera side, which means the camera does not have a very good understanding of the content that is present. So then, how would the camera really know which style is relevant and what is not relevant? So here, then we start on a completely different tangent here, which is that we make an observation that is it possible that there is some correlation with some parameter of the video with the number of objects. Okay, so here I will just specify that I have two assumptions. One is that the camera is static. Okay, so I'm talking of the static traffic cameras. I don't consider in this study dash cam videos and so on. The second assumption, which we can justify, is that in such scenarios, mostly wherever there are changes, right, in the content, we care only about the changes. We really don't care about the places that remain unchanged and so on. Okay. Now, once we do that, so then we have what are these number of objects that are present, which are actually moving and so on. So we see that there is a correlation between the file size of each tile with the number of objects. Okay. So this is the correlation graph that, and if we quantify it, we see that this correlation comes from something like 0.75 to 0.9, and which is considered to be very strong. So why does this happen? Okay, there has to be an intuitive reason that why does the size of the object, size of the file corresponding to the presence of an object increase in that situation. To understand that, let's look at how video is usually encoded. Okay, and this type of encoding is followed by all of video standards today. It's not just limited to one, which is that wherever you have a lot of these changes and details, right, you require more fine-grained information because you can't use prediction from the previous content to encode those points. Okay, so what you would observe is that in this spatial portion there are more additional details that need to be encoded here, and because of that you have additional bits used. Now, once you have additional bits used, then each of these tiles, wherever there are these objects of interest that are present, would have a higher number of bits used to encode those tiles. And potentially, you could see these types of increase in the file size of those tiles as a result of that. Now, the question is that can we utilize that bitrate to really filter the irrelevant types? And it turns out that we potentially can. If we look at this heat map, that we see that as soon as a car goes past, right, we see a rise in the file size of those tiles. So on the left side, the car was actually to the left. So we saw a rise in the bitrate of those tiles. Now the car has moved to the right, and we now see that the bitrate on the right side has increased.
One question
Yes.
over here. So is this the file size? What's the so usually for like a video encoding, we have group of pictures.
Yes.
For the video segment. So for this file size, how long of a duration? Is it?
Yes. So we are using segments of half a second.
And how long does it take for this car to drive off this?
So it will take, like, we assume that it takes more than half a second or so.
Okay.
Yes.
So the top of your scale there is 1.8 megabits per second.
Yes. So now the question is that if we want to use these bit rates, then is it actually, can we use some sort of thresholding scheme to filter out that where are the objects present and where are they not present, right? Technically, we should be able to based on this observation. But it turns out that there is some amount of noise in this bit rate, okay? And you will see here that there is this blue line here, which blue bar, where basically there is, it does not have any object, but it has a relatively higher size than the other cases. Okay, so there is some amount of noise present, which means that the thresholding needs to be done with some intelligence in mind. Okay, although the spikes show the presence of objects, but we need to identify the right threshold. And here comes some interesting challenges, that because it's not as easy as it initially seemed, because that threshold that we want to pick is affected by multiple other factors as well, including what is the lighting conditions, okay, what is the background, which means that effectively you see that on the left side I show that, look, I have these 8 tiles, okay. Now all 8 of them have different bitrate statistics. Not there is very little similarity across tiles among the bitrate statistics. Okay. Now you could ask why it was not so in that picture, because that picture had only that road as the background for all the tiles. Okay, so it simplified the problem a little bit. But if we go to a realistic scenario, then we find that we have these different statistics, and we need to find the threshold for all of them separately. Okay. The second aspect is this lighting condition. Again, because of the intensity of light, or there might be rain and so on, you would see that the actual bitrate of the tiles, because of the way videos are encoded, would keep changing. Okay, they would not actually remain same. And and effectively that leads us to conclude that the threshold that we choose should be adaptive and different for each type. Okay. Okay, so now what we do is that we actually try to create a system of cluster of these tiles, so that basically the idea is that we have we want to have 2 clusters, one with objects and one without objects. Now the question is that how do we identify this cluster? Okay, so because I said that there could be lightning changes in lighting conditions and so on. So the first thing that I would like to emphasize here is that we don't want to use the absolute stat values of the bit. Okay. So what we do is the percentile of the statistics throughout, because we want to go with the relative values always. Okay. So on the relative values, we need to come up with the threshold. And here we do, of course, we will do for each tile independently. Okay, so we are not using any correlation across tiles and so on. it's each tile independent statistic. So how do we choose this? Suppose if we have a high false negative, so if we choose the threshold to be too high, we would have high amount of false negatives. Okay, what are false negatives? False negatives are cases where there was a vehicle, but we could not detect them. So it mistakenly said that no, there is nothing. So it did not send. Whereas false positives are the opposite cases where basically there was no vehicle, but it still decided to send the content to the server. Okay, so we want to balance these false positives and false negatives and so on. Okay, so that requires us to find this. When we said that we need this clustering, so we require some calibration to find this right percentile values. Okay, and we want to utilize the median of these two percentile values for each of these clusters. Yes, so segments are is a single group of pictures with a total of 15 frames in our case. Okay, so we are not removing any content at a picture level. Okay, we are removing at a in spatial terms we are removing at the tile level, but in temporal terms we are removing at the level of this group of pictures or segment level.
Segment of something for the 15 frames.
Yes.
20 segments.
I just have a question about the order of magnitude of this. I remember your first slide, right?
Yes.
You get about one fatal accident per camera on the planet every 10 years.
Mm-hmm.
Okay. That means that if you're throwing away frames based on positions where things don't happen much, you have to go way out on a power law tail to get those. In other words, I'm worried about you throw away the frames that have that one unusual event every 10 years. By looking at, there's a tail in this distribution, right?
Yes, I agree. There's a tail in the distribution.
And the rest of the traffic data is sort of ordinary. You want to ignore that.
Okay, not really. Okay. The reason being that there is an assumption that we want to catch only the traffic accidents, right? But we want to catch traffic violations. Occasionally, we want to catch all traffic movement. Okay.
Violations, though, you're the same statistics. It's not a question of 1%. It's a question of 1 part.
Yes. Yes.
You don't have everybody going by 10%.
Right.
On
yes. So effectively, you could argue that so if you look at the use case of this, right? It's not just to catch traffic accidents. It's to say analyze traffic patterns. Okay. So to understand how to plan infrastructure and so on. So all these together form part of this traffic safety project that people are interested in.
That still troubles me a little bit because if I'm investing in money for infrastructure, I care not about the 10% effects, but the massive effects that occur once a year or something. I want to be sure that I plan for overages.
Are you? Yeah. So
I'm just concerned that if you throw away stuff, you have a threshold, you throw away the 1 part in 1,000 things, you miss the 1 part in 1,000. And which ones matter? I don't know.
Okay. So yes, I understand what you were talking about, right? You are saying that we could really end up removing something important while. Is that your question, or
yeah, it's essentially the cars that drive on the sidewalk on Christmas Eve in New York City.
Yeah.
If you miss those, then you don't put up barriers.
Yes, I agree. Yes. So effectively, we require a system that would really catch the anomalous cases. Yes, I agree with that. Yes.
But yes, it depends what the higher level app. Catch multiple events. It's not looking.
Yes, this is looking for more. Yes. But something that could be done is that this is one level of filtering. You could potentially, which would catch even like it's not very low probability events, it's a relatively low probability. You could have another higher level of filtering built on top of that, which would potentially be run on the cloud systems to detect accidents and so on.
Post-op.
What is it?
You could run that offline.
Yes,
because it
yes,
didn't have
yes.
to be a-
Yeah.
You know, I have to tell you, this is a true story, and I'm really impressed with the system. My sister, this was 3 years ago, had gone shopping, and then she got dropped off at her house, right? And so she had multiple bags. So she got out, and then she was taking the bags out of like an auto. I don't know if you know what auto is.
Tuk.
Yeah, it's like a different. So it's kind of open and all, right? So she was taking her stuff out, and while she was doing it, she put her iPhone on the seat, and the guy just took off. And she didn't have time to note the license plate number, nothing, and he immediately turned the phone off. And she called the cops, and they caught them within 4 hours based on their traffic cameras. Right? So I was really impressed. I said, like, man, I didn't even know these things work. I don't think they did.
No, they do work. Yeah, they do work.
Amazing. I couldn't believe it.
But they don't work with an automated closed loop system.
Yeah.
Yeah.
So I'll ask you about time scale, right? that
Yeah.
you're looking at. It seems like you just have data, you go and look for this event, right?
Right.
And I guess somebody dropping a passenger off from a way is an event. It's not you don't think it's anomalous from the camera's point of view. Right? So, yeah, but I was really amazed at the success of that.
They find it fast and you can find it with the iPhone locator.
No, he turned the iPhone on.
Oh,
That's the first thing he did. Right? She
Really?
immediately ran inside and said, "Let me try to locate it." With my brother-in-law's phone, and it was turned off immediately. Right? So, yeah,
This was in which city, by the way? Which
Huh?
city was this in?
This is in Chennai.
Okay, but this has this problem that if you want to use this calibration, we have to do it at runtime. Okay, and we do not really have access to the ground truth there. So what we do is that in general, what we send the data to the server and for the first 30 seconds, and we exhaustively search all the possible percentiles from 10 to 90, okay, for each combination of percentiles. And then we maximize the F2 score of this, okay? So for people who are not very familiar with what is F2 score, it is the weighted harmonic mean of the precision and recall. Okay, so maybe I'll explain this a little bit that why we do this harmonic mean is that in general you could use arithmetic mean or geometric mean. Okay, but harmonic mean automatically prioritizes the value that has a lower value. So the parameter that has lower value, which is relevant in this case because you don't want either precision or recall to be low. Okay, so effectively that is what is this. You will see this F beta score being talked about. Now that 2 is the amount of weight. Okay, in this case we actually give more weight to the false negatives because false negatives are more expensive. Now, in those cases, so that's called F2, basically a weight of actually 4 because 2 square is the weight. So F beta score effectively gives a weight of beta square times on whichever is has higher priority. Okay, so this is the logic of how that selection process works. Now let's come back to the architecture because I have explained the selection. So initially I have a tile video. Okay. So after that I apply the heuristic for selection. Okay. Now there could be two possibilities. One is that the heuristic is already calibrated. In that case, I go straight up to number 5. Okay. If the heuristic is not calibrated, then I need to send the entire video to the server, and there is a calibrator that is present, okay, which is calculating whether we have, whether there is, whether what is the statistic for which I am getting a good value. Okay? Once that is done, it only needs to run for the first 30 seconds. Once that is done, I tell the heuristic that look, this is the threshold value for each individual tile, and then it can do a tiles level selection. Yes.
So how do you decide the number of tiles?
Okay, so we use exactly this 4x4 configuration of that. Okay, in all videos. Now you could ask that why this configuration, and this we actually sort of empirically justified it, saying that look, we tried other configurations, but it turned out that for most cameras, 4x4 is the right amount of tiles, because encoding using tiles also has some overhead because the video content has to be independently encoded. Okay, so having too many is also not a good idea.
Does the camera firmware natively support H265 encoding?
Yes, it does. Yes. But there is a catch here, which is that even though it supports H265 encoding today, it does not support the tile feature of H265.
Okay.
Yeah.
So does that actually require like because you need a server?
Okay, so that is up to us. Okay, in this case, there is no need of firmware change because we need feedback from server, but you could potentially connect a Raspberry Pi or similar device to the camera because we don't remove frames, we just remove tiles. So provided you have the video encoded as tiles, you don't need a firmware change.
Basically, you had another device up.
Yes. Yes, which is actually cheaper than using firmware change. Okay, because filtering frames require firmware change.
There's
So yes, actually there are smart cameras nowadays. Okay, the problem is you can't program them. Yeah, the logic is embedded in them.
have you tried access cameras? I mean, I did some with civil engineering. So first thing first, our cameras is on a very and then those cameras currently only support that's the precision.
Yeah, 264 did not have tiles. Yes.
Is it possible to apply this to cameras or
264?
yeah?
Technically it is, okay, but there are some challenges, which is that if you want to remove the spatial content, right, then it becomes very compute intensive and you can't do it using Raspberry Pi. So you would have to use something like an Intel Nuke and so on. Yes, on the camera side.
So even with 265, is it possible just to like for user to define how to actually manage to actually get a better result?
Yes.
Just do square tiles, different rows have different like sky width. And it's not at all because you don't.
Oh yes,
Is it
definitely.
possible to for
Yes.
user to define a tile like a tile?
Yes, it is possible. It is possible. It has to be rectangular, but they need not be of the same dimensions. Yes.
They cannot be larger.
They can be larger or smaller,
Because I mean,
but
from my
it has to be rectangular.
oh, okay.
Yeah, it need not. So here it might look as if they're squares, uniform squares. Okay, that's not needed.
Okay.
Okay.
Is it more tile you have, the accurate like a because you can draw better shape and
Yes,
more?
technically yes, you could. Okay, the more tiles you have, you could increase your accuracy more and more, and you could improve that would improve your savings. But as I said, that yes, there is an overhead that comes.
What is the latency of this tile?
Okay.
Or like full times 4 times 6.
It's proportional to the number of tiles, basically.
So what's the latency?
I think I have the number in a later slide, so we'll come to that. Yeah. Okay, any other questions on this? So I'll just come to the evaluation. So again, for evaluation, there is an important aspect I would discuss this, which is that in general, we use this around 50 videos with a total length of around 4 hours. Okay. So the first two videos are from benchmark datasets. And the first one is mostly from the US, the second one is from China. So these have been used by prior papers. We have also collected some videos from India, and the reason I wanted to mention this here is that the first two benchmark videos are from roads that are very well structured. Okay, and but the Indian videos that we use, those are on roads that are not so well structured, which means that there are like people, like it's not a two-way road. People are going along either this or that way, and so on. Okay, and I believe in the long run, traffic surveillance projects need to focus on those cases, because those are the cases where actually today we have a lot of unsolved problems. So this we encode use. So whoever wants to use this, there is a tool encoder called Avazar, which encodes it in software. So we downloaded the benchmark videos and we use ELOP5 by Ultralytics to get the ground truth. So it was pseudo labeling. Okay. So we compared against these baseline techniques. So reductor, PDS, static time removal, and cloud sync. So I'll very briefly explain what these were. Okay, if there is time, I have some slides to explain them in more detail. But for now, I'll skip the details of these systems. So reductor uses frame filtering. Okay, it came out in SIGCOMM 20. So the idea is that it tries to form clusters in each frame and identifies whether the frame is relevant to the end application or it's not so relevant. Okay, it uses low level features of the pictures. So DDS does something different, which is that DDS sends the video at a lower quality all the time, okay, to the server. Now, if the server reports that, look, at these positions, I'm uncertain about the content, then the camera is programmed in such a way that it can get a second request to send the data again of those relevant parts at a high quality. Okay?
So the camera is actually buffering the video.
Yes, camera is buffering the video in that case.
How long, like,
It has to be less than a second.
okay.
Because, yes.
Just settle the keyframe.
Yes. Okay. So this was actually, both these works are very highly cited by now, like with well over 100 citations at this point. So the next is static tile removal, which we did it, it's not been proposed anywhere, but we thought it was a natural thing to try out, which is that I think one of you mentioned that it's possible that there are a lot of background content where no object ever appears. For example, it points at maybe a position completely outside the road and so on, maybe at the horizon. So we manually strike those up and see how much savings we get. And then we try this cloud check, which was at hot cloud. So it had a very simple idea I talked about, which is that just send the video at a lower quality and use super resolution to enhance it on the server. Okay?
Doesn't super resolution have the same problem in that it injects features that are normal, what you expect?
Yes.
So they miss by definition things which are.
Yes, it does have. Okay, and I am not sure whether because we did not have a catastrophic accident or something in the video, so not sure whether it could ever be adopted in the real world yet.
Super resolution, like if you have a license plate, when you go, it's sending on low quality to the server. The license plate will perfectly off.
I think recently there have been a lot of works on super resolution to resolve this problem. It's not a completely solved problem, but there has been a lot of work still going on to handle this.
License plate spawns have a very limited space they do that.
Yes.
So you should be able to pull that.
Right.
I need a database that includes license.
Just
Right, exactly. We need a database that includes the license plates.
Well, special.
Yeah. So I'll skip the details of this system, but I can come back if it is really we have time and if there are additional questions. So first, let me explain the results of this. So when we look at what do we mean by accuracy is that for object classification and detection, which is annotated with the large model of yellow V5, how do our results compare? And here we see that actually the super resolution system called CloudSeg is the best overall. Okay, so CloudSeg is the best system. TileClipper comes after that. TileClipper is the second best. And TDS is actually very close to TileClipper in terms of accuracy and safety. Yeah, accuracy is that when we get the same result as the yellow V5 model using our system, using any of these systems. Yes. Right. Actually, the ideal accuracy metric would have been if we compared it with a human annotator. Okay, but it's video, so there are a lot of frames, so it's not easy to do human annotation. No, not frames. It's the file size. So there's a difference. I'll let you know why. It's a good question. Because if you have fewer frames, right, also your video encoding would become less efficient because there's less amount of interframe prediction that you can do. So the improvement of by sending fewer frames is sort of compensated somewhat by the fact that your encoding is less efficient. Okay, that's why using number of frames is not the right metric here. You should re-encode the data at the same quality and see what is the size of the data. Okay, so you might ask that then why is our system TileClipper preferable to that of DDS, right? So then comes the next question, which is that how much of server is being used by each system? And it turns out that both CloudSeg and DDS tend to use the server almost all the time. Okay, and that is natural because CloudSeg is doing super resolution, so it needs all the time. Okay, DDS, what it is doing is that it is basically getting a query from the cloud that whether it is able to infer correctly or not. And if it is not able to infer correctly, it is sending it a second time, which means that it adds an extra overhead, which is almost being used all the time. Okay, and this is the key disadvantage of actually the DDS system overall. If we compare it to the others, it does improve accuracy and so on, but it also increases the amount of GPU usage that we have. And so because of this, we say that TileClipper gives the best trade-off among accuracy savings and GPU.
How about the sensitivity?
Sensitivity.
So how sensitive is the tile?
Yes. So
if a small
yes, good question. Because it depends on how small it is. Okay, as long as say we observed that yellow V5 cannot detect anything if it is as small as 1/16th or smaller than one time. Okay, the content. And in those cases, we assume simply that those don't exist. Okay, so it's benchmarked on that data. But our data also had pedestrians, not just vehicles. Okay, so it was able to detect pedestrians walking, and it was able to detect any changes in the traffic light signals.
So that means TileClipper actually is more sensitive than YOLO.
No, I would not say that. I would say similar sensitivity. Yes, because we have no way to compare whether it is more sensitive because we didn't try to annotate with anything better than yellow fever.
Oh.
what's the downsizing or just resolution ratio of TILECLIPPER?
So actually, we did two different things. One was by 2 times, and one was by 4 times. And I think we used whatever gave the better result. Yes. 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 This-
Qualitatively, like, for me, what would be the better option? I am very
in terms of you have to look at in terms of what, for example, say savings wise, okay, obviously reducto gives a slightly better here, okay. However, you see in terms of accuracy you have a good amount of reduction there, okay. And actually this was something that even the reviewers commented on, that reducto actually in their own paper said their accuracy is over 0.8. So why did in our paper it go down to 0.6? Okay. Now there is an answer to that, which is that in general, because of the type of application we are using object detection and classification and so on. In general, we need a quantization factor of around 30 or so. We don't need better video quality. Okay, now reducto works much better if your video quality improves a lot more. Okay, so if you reduce the video quality to what is required for the application, you will see that reducto tends to its performance tends to fall because it cannot extract the low level features as efficiently anymore. So the thresholds tend to fail. Okay. So yes, here's the processing speed that I was talking about. That so we wanted to not add to the existing compute, right? So that should be both on the camera side and on the server side. Now for TILECLIPPER, you see that we are, so I assume that 16 frames per second is the bare minimum required. So we got some on Raspberry Pi for 22 frames per second. Okay. And on Jetson Nano, we get, I think, close to 60, around 60 frames per second. So DDS, of course, did not have that objective at all. DDS is much, much slower. Okay. CloudSeg is actually has no extra overhead almost on the camera side at all. So it's almost same. Okay. Reducto is actually much, much faster than all of this. Simply because Reducto only requires the low level features, which are very easy to gather. So Reducto is the fastest on the camera. Okay. But we also satisfy the real-time constraint. On the cloud side, you have something more interesting, which is that all of them depend on regular utilization of the cloud. Okay, and this, especially this Reducto, which says that it does not, it requires only calibration. It turns out that the calibration need to be periodic for it to be used. Okay, whereas when we use TILECLIPPER, we saw that because we are using at percentile values, we are not using the absolute values. We need just one-time calibration. So even if the weather conditions change, as long as the camera has not moved, we don't need to do any recalibration. Yes.
Nighttime and daytime, the light vary.
Yes, it will still not matter.
Still,
Yes.
no extreme weather.
Yes, it does not matter. Yes.
Okay.
And the reason being that because your background is still similar. Okay. Now what happens is that your tile statistics have changed, but the relative changes stays roughly same.
Oh,
Okay. So that's why we use percentile values, which means it automatically uses relative values.
but when, for example, snow weather, extreme weather is when there's objects actually flying from the sky.
Yes.
It will trigger the whole pile.
In general, that's not how it seems because they come very close to the lens. Okay, so the entire thing becomes hazier.
But
Yes.
for example, snow, you have snow everywhere.
Yes.
So actually, basically they are like white spots. They are
Yes.
What?
No, it will
No,
not
it will
trigger.
not.
It will not trigger because what will happen is that so a few cases, so it will not trigger recalibration. It will initially trigger some false alarms. Okay, so you will false positives, and then gradually the percentile will again become stable.
Oh yeah.
Okay, so it won't trigger recalibration. Per second. So effectively, we have less overhead on both cases. So I'll just explain the live deployment setup. Okay. So we actually deployed a camera on the road. And so it was 5 meters away from a two-way road, and there was a 30 km/h speed limit. So the road had a mix of vehicles and pedestrians. Okay. And we used a 4G network to stream it to our campus server. And we saw that it worked in this way, that we have both high accuracy and savings, both at 30 frames per second and at 10 frames per second. Okay, so I will now summarize our system. So streaming videos to the cloud incurs high bandwidth and latency. So TILECLIPPER utilizes tile filtering to amortize the streaming cost. It leverages the correlation between the bitrate and the number of objects. Okay? And we have evaluated it on diverse datasets under various lighting and weather conditions. And we show in real life deployment that it is practical to use. Okay? All right. Any other questions?
And used for a application. General.
It can cover any video analytics. How I can explain? So almost all video analytics, the basic block is object detection and identification. Okay, so if somebody wants to do tracking, for example, right? So it's again object detection and identification. So our basic block is the object detection and classification. Yes, there could be. For example, Reducto did something on counting and so on. Okay, so we don't actually handle any application that requires less detail than object detection. There could be there are many applications most applications require more detail than object detection and class. Yes, yes. Yeah, that is actually something that a few others have tried. That what features should be useful and so on. In fact, Reducto tried that. But overall, I would say that counting and sort of similar, like I think they had two less detailed applications. One is whether there was presence, which we also handle, and there was only counting that we actually we are not considering in this case because we are sending way more detail than what counting is. Yes.
I have one more question about how the tile actually activates when you
Yes.
For example, I see you presented like some of the tile appear more object and more colorful. I think actually the normal range will be very high, right?
Yes.
So in that case, if something that is similar to the background appears in the ring, will it be more likely than other tiles in that case?
Okay. Yeah, that's a good question. So I can give you an example to say what sort of thing you're talking about. Okay. So if it's a black car on a black road,
Yes.
or something like that, right?
Yes.
Yes. So we actually tried this on some test cases that were more challenging sort of. And it turned out because even if the object is look similar, it has the edges, okay, where where there is sufficient amount of changes to trigger the system.
Okay.
And
So what if the tile is already very noisy, like there's a lot of edges and there's a lot of colors already, and you have another object coming in?
Yes.
Similar?
Yes,
Or
in
different?
that case, there might be a like number of false positives triggered.
Okay.
Okay, so one reason why we used F2 score as opposed to F1 score is that we said that in these cases let there be more false positives.
Yeah.
Yes.
And so it only transports the tile. The rest will be black.
Yes, the rest are black. Yes.
Okay. Can that actually be applied directly to RCTs? Actually, that's what's underestimated.
To TV screens.
RSTP screens, real-time streaming.
RTSP.
Yeah.
Yes, RTSP. Right. Yes, they can be provided your receiver has a little bit more intelligence. Okay, because then what you like if you show it directly to the viewers, right? Then viewers would be very disturbed to see suddenly some parts becoming black, some parts becoming visible again, and so on.
Yeah.
Okay, so what you need to do is that there is something called a computer vision technique called pixel synthesis. Okay, where even if you don't have the content, you interpolate the content. Okay, and this is very common today in using NVIDIA's. I think NVIDIA has a framework even to do this.
Because I worked for that highway for violation purposes.
Yeah.
And violation need actually
Yes.
you need surroundings and
Yes.
I'm just thinking about that. If for violation purposes, this not a good idea.
Okay, that is a good question because you see, in this case of violation that you are talking about, right? So, assuming that there is no other activity around you, okay, the other tiles will remain, will be blackened, right? But you don't need to show the black part. Instead, you can show what was the last time it came because there has been no change since then for the other time.
Use the previous frame.
Yes.
Actually feedback.
Yes.
Because,
Yes.
Yeah, because there's laws we need to fill in university. We avoid the laws.
Exactly.
We should make no modification.
I see. I was not aware of that. Yeah. Yeah.
And also, is it possible to change the sensitivity for each tile? Like after you default calibration, I want even more like possible.
Yes. So where I said about F2, right?
Yeah.
So actually F2 is this. There is a score type of score called F beta score. Okay. So as you increase the value of beta more and more, it becomes more sensitive, and so
Okay.
okay. And you could also there is also some people who say that things should be less sensitive. Okay. You can also take the value of beta to 0.5 and so on.
Yeah, because I think less sensitive is. So there's different conditions. Traffic monitoring and there's like image monitoring.
Right.
You want the whole battery and it's not moving at all. So most time it will be black. Okay.
Yes, even though we only yes, I agree with the use case, but we did it only on the traffic situation. Yeah. Any other questions? Okay. Thank you.
For this time.
Yeah.
By the way, is there any optimization ways to optimize tiles around large objects? So I understand the worst case is actually there's a vehicle on the edge of all the tile, which actually triggers all the tiles.
Yeah.
For language, if something is very zoomy just to a lane, so actually when the vehicle passes, the whole tile will be triggered. Is there any way you can actually
Yes, it could.
optimize the tile?
Yes, you could. Okay, so we have not done it, but we thought that if you could use the spatial correlation across the tiles, right?
Yes.
You could potentially
Get better
actually.
result, right?
Yes, yes.
Okay. And how much like for example smaller tiles, 6x6 tiles? I remember you showed that.
Oh yeah, I
I
think
want to see like a 2x2 and a 6x6. What's the difference on raster? I don't know, maybe yes.
okay. So I think yes. So just go to that frame rate. Yes, you see here you get something
That's
like
4x4, right?
yeah, this is 4x4. Now it is proportional. Okay, so if you do something like 2x2, it will increase to some. Now I'm getting 16, so something like 24, 25. And no, I'm getting 22, so it will come to around 30 or so.
Oh, so
Yeah. And 8x8 actually goes below 10 frames per second.
6x6 already going below
It's 8 by we didn't try 6x6, we tried 8x8.
8x8.
Yeah.
Because I think 5x5 or 6x6 might be better, and also always is focus center to where the zone you're interested in, right? So maybe your
Yes.
tile better arrange. There are larger tile in the middle, actually smaller tiles at the edge. Because I mean, normally when you put a camera, you actually focus on the zone you are using.
Yes, that could be one possibility that I don't know whether anybody has tried it. I don't think anybody has tried it yet.
Because this rectangular tiles, I mean, I have an object actually any violations in the New York City highway. Actually, and the way and we use ALPR, use vehicle detection.
NPR, yeah.
The first layer just to detect everything. Actually, we use near the edge company instead of on edge company. So actually, there's no data directly sent to the server unless it actually requests okay with the violations. That's like near edge company. I have one computer controlling 6 of cameras, vehicle detection. All detection first, and if it's a vehicle, then do vehicle detection with the model name, then the license the image that